So today's topic is going to be about the VMX and how it's our solution not only for high quality survey, but also for GIS applications. And for those of you that may not know, GIS, of course, is the graphical information systems, often associated with programs like ArcGIS from Esri. There are a couple other GIS tools out there that are not Esri as well, but Esri is a big player in this market, of course. And this serves along the lines for folks that are managing assets throughout counties or cities and states here in the US or provinces in Canada, what have you. And it's a great way to collect a lot of data, and they manage it. So welcome, everybody. We're going to kick this off now. So my name is Josh France, as many of you know, and I appreciate all of you for logging in today and listening to another exciting webinar by myself. So a little bit later on in the presentation, we have a message from Dr. Harald Teufelsbauer that hopefully will play correctly. It was 50-50 on it yesterday. We'll see if I can bat 1,000 today. So without further ado, we're going to get going here. I have a fairly aggressive agenda to cover in just 1/2 hour of time today. So let's jump right into it. So we're going to cover the hardware aspects of the VMX series and the VMQ for good measure. And we're going to go right into the MLS software workflow. So without further ado, I present the present and future of our mobile mapping systems, the VMX2HA. And the reason why I say future is because with all the additional camera add-ons that are possible with the VMX2HA, there's a lot of future add-on capability that could come out. And we've already made strides with that in terms of adding on the pavement cameras. And we have some new cameras to talk about today as well. But the focus of the VMX2HA and really the VMX system has been the dual integrated scanners. So that's the two VUX1HA scanners you see there at the top of the system that are tightly coupled and well calibrated. This tight calibration between the scanners, the INS GPS system, really make for a well thought out solution that provides very high accurate data to you. So with the addition of the new camera system, which is a very flexible system, allowing you to change the angle of the cameras to meet your collection's needs, provides a lot of choice for you. And it allows great user adaptation. So what do I mean by that? Well, I mean that you can plug and play this system on various mounting platforms. So you see here a survey truck. You could take the same framework and attach it to a boat perhaps, or a high rail truck, which would be very similar to this setup, of course. A locomotive engine we've done, different type of cars, small side-by-side scanning platforms such as a John Deere little tractor. So things like that can be accomplished with it very easily. So the big focus and the big change from previous iterations of the VMX, what has been the way we've added on the camera system. So I like to call it's the scanner and camera system of the VMX2HA instead of the VMX 450, 1HA, 250, what have you, with a camera system. So this is, and that was AND. So it was an add-on package. This is a combined complete package. So I use the AND camera system phraseology for this. And you see the big feature here has been the additional pipe to push data down through. So now we can collect at higher frame rates for every camera all at the same time and not lose any frames. Very complicated thing to pull off, and we're doing it seamlessly. So a little bit about the camera storage and setup of the system. You can see from this graphic how the cameras detach. Everyone always asks, how tight is that? How secure is that? Can you move them after you lock them in place? Well, the answer really is no. You can't really move them once you lock them in place, pending you tighten all the different places that it can be tightened up. And you can see here is our transportation case. So it's a very portable system. It does ship on a pallet. That is a big case. However, it holds a lot of different cameras and accessories. So really what's left out that you can't fit in that case is a roof mount and the CU box, or the collection box. And speaking of the collection box, this is our new and improved VMX 2HA control unit. So you'll see here some of the features. Everything's on a single computer this time around. If you're familiar with earlier VMXs, you know that we had dual computers. Now we have just one. It has a really robust and reliable power subsystem, and that's key. So this isn't a battery powered system. It's not running on a rechargeable battery. It's running off the car's power, and it's also charging up a secondary backup battery in case the car's battery power gets decreased by running the system for a very long period of time, where you have to shut off the vehicle for safety reasons or for something else. You have a backup battery that is charging that can run the system during that interval or that interruption to typical power service. So it's very well thought out. And then even more critical these days has become the ability to remote access the system, to be able to be somewhere else and still pilot the system. We've had several users take advantage of that as a preventative measure to reduce their exposure to their crew members, to not have to have two people in the car at the same time. So a lot of innovation there. Again, this is a single connection. So a single connection from the rooftop where the scanning system is down to the CU box. And that sort of is our overview of the VMX 2HA. So I'm going to transition here to the VMQ 1HA. So the VMQ 1HA is a single head system, of course. It's tightly integrated with an INS GNSS system, just like the VMX, with the advantage that it has a swivel plate that allows you to swivel it back and forth to get different angles during your collection. So that just means you're merging multiple passes to get similar point overlaps as you would get with the VMX, but you're taking two drive passes instead of one. So it has further advantages in the case that you might want to do a third pass and change the plate again, which allows you to cover more of the hidden spots. You know, you have parked cars along a roadway, and you can swivel it to maybe a perpendicular direction, like in the 0 position, as you can see here, and you get a little bit different look, and you're not sort of blocked by a car or an object in the way. Can't see through things still, but it just changes how the laser pattern interacts with the surface of buildings and cars and sidewalks and curve edges. So with the VMX and the VMQ 1HA, we can put on different camera options. You can see that the cameras are slightly different in the tech drawing there. They sort of have a bulbular shape instead of a tubular shape, would be the main way to describe the difference. But both the 5 and the 12 megapixel cameras are available for both of those. And that wraps up the acquisition systems and their main highlights. So we're going to jump right into how do we collect the data. So that's also the same for both of these, and that's with RIEGL. And there's a lot of great features in RIEGL. Some of my favorites are presented here on the slide, but really being able to automatically log and rename files based on the naming convention provided in the KML file has been a really key addition that really helps organize and control your data acquisition processing. Also, the pause logging methodology is also really helpful in urban environments or areas in which you can start and stop the scanner, so you're not having to constantly communicate with the passenger and make sure the operator, I should say, not passenger, they're operating, and make sure they're paying attention to the start and goes at traffic lights. If you've ever done that process before, you know that it can be quite challenging to get that timing exactly right. And the real key is that you can see everything that's happening. You know what the data looks like when it comes in. Of course, you can have almost too many cameras nowadays, but you can still see them all, as well as you can see the reduced point cloud view from the top on the screen at the same time, and everything's color coded. So if there's a problem, you're going to know it very fast by the color change of the windows. So what else have we been doing? So we've been changing and adding some options for our camera systems. A few years ago, we moved to our CMOS chips to help with the quality of the colorized point cloud and to capture more of a true color look in the real world. And you can see that we're also able now to adapt the region of interest. So we're able to crop the images a little bit and get a slightly different megapixel size out of each of the 12 megapixel cameras can be reduced to 9 or even 5 by just windowing down what it's looking at. If we then look at some other additions, we've also added a new lens option for our 12 megapixel sensor. which is a 16mm lens. Our standard before was 8mm, and so that gives us a smaller footprint further away for the same field, for a slightly reduced field of view. So if we take a look at what that looks like, one of the big benefits to this is it's going to help you capture things further away with better resolution, which allows you to take maybe fewer pictures. So you can see the very clear advantage the 16mm lens offers on a forward look at the same object that the 12 megapixel 8mm lens was taking of the same thing. Now they're both pretty readable, but it's definitely crisper in the 16mm lens image. So some of the other new updates, as well as some of our housing has been new and improved for the cameras as well. But now we're going to take a look onto the other major area of focus and attention at RIEGL, which has been our overview, which has been our software development. Right. So having a good process to get from the start to the finish of your job, which in the RIEGL world that we're taking care of and paying close attention to, is getting to a precisely georeference point cloud. And so we're going to walk through some of the steps that you can use, and I recommend you use for pretty much every job, that will help you produce consistent quality data. So the very first step, after you've of course copied the data over and followed your best practices for saving data and making sure that you are keeping backup copies and keeping all good records like you should do, is to actually start the data processing wizard. And you can see we've added some steps since the early days of the data processing wizard, namely that we've added to it the trajectory import step. So now in one location, you import the trajectory, you start processing the data, and you get the data ready for viewing, all in one step. So pretty easy to use. So I always recommend, so as you can see, I should take 30 more seconds on this slide. I apologize for jumping ahead. You can see there are other steps you can have it automatically do for you as well. You can have it automatically run RIE Precision, and you can have it export the data. And it's very tempting to say, yes, just go ahead, run RIE Precision, trust it to give you all the right results, and then export it and start feature extracting, and you'll be fine. However, let's use some caution in that, and I'll show you why here in a little bit as we go into some of the next steps, which are visual inspections, and of course adding high quality survey control points. So the best way to check data really has been to do a 2D plot. And so this is a 2D plot view where anything under 2 centimeters is black, and anything above it changes color slowly until you get to white, which is above 10 centimeters. And obviously the trees and the bridge overpass are going to be a different color because there's further difference between the top and the bottom scan passes. So you can see right here at this on-ramp, on-off ramp interchange area, there's a lot of areas of concern. There's probably some areas of concern out here as well as right here with some overlapping data. So this is all just after it's been run one time, no post-processing, no alignment, and then really to inspect critical attributes. If your goal is to model the support structure of this bridge deck, you need to check it and see what it looks like before you run RIE Precision. So that way you can A, speak intelligently about whether it actually did anything positive to help you, or B, make sure it's even in the right line, lined up right. So I mean, if you had one pass that was, way below everything else, you might want to go back and figure out, okay, what happened there? Why is that off? So little things like that go a long way in smoothing your workflow process. So now we need to add ground control. And we've done a lot of work adding more markers for you to use as surveyors during the data processing steps. So we've added initially some automated detection with these two shapes, and we furthered that by adding in chevrons and circular discs. Now these can be placed on flat surfaces on the ground or on walls. So you can get both vertical and horizontal targets detected there. They're user defined, so those A, B, and U's are all user defined parameters. So you can place those on the ground, and you just want to keep in mind that the faster you drive, the larger the targets need to grow, right? So if you're driving at 90 miles per hour down the highway, you better have some pretty large chevrons or discs or checkerboards in order for the scanner to pick that up. Just saying. Not endorsing high-speed mobile mapping beyond the speed limit, just to be clear. So once you've done that, I invite you also to run a scan data adjustment analysis report, which is what this document shows. And it just gives you a quick look at the overall vectorized offset numbers. So that's what this is showing you. This isn't showing you X, Y, or Z. This is showing you X, Y, and Z all at once in a vector, what the overall deviation is from that point. So it's a point-to-point vector result here. But if there are results that are very far removed from what you're seeing from everything else, it's a good hint that you need to inspect that further to make sure that there's not an error on your side or the program didn't make a mistake. After all, computers can make mistakes. Then you can run RIE Precision. And for those that may not know RIE Precision, let me give you a quick overview of it. I won't spend too much time on that, as that could be a whole entire webinar and probably a course over multiple days on this topic. But RIE Precision is our estimation engine. And basically what it's doing is it's taking input from everything that we can assign a value to. So we can assign a value to the accuracy of the laser scan, the trajectory, control objects, and then we can generate further correspondences in overlapping features, right? So buildings that you pass, the Jersey wall barrier that you pass, the stop signs, the overhead signs, even the power lines can become objects and correspondences that the system can look for and inspect to see where the variations are. And what we're doing is we're modeling a new trajectory that improves upon the original in areas that it needs to. And so this creates this optimized result, which then should result in a definite point cloud. So now you can see that same picture from before now is all dark blue because everything is under 2 centimeters. And I did change the color palette just to make it pop a little bit more. So we have very clean post-processing. There's a few smudges in there that just need to be inspected. They're scattering of points from a cross path that can be filtered down by reducing the overall range processing performance of the laser before you go to export it. So overall, great results. Of course, then you check your control points again, and so on. So really the last step in this workflow is to do a colorization of the point cloud. And to do that, first you have to adjust the camera mounting. So like I mentioned before with the cameras, they're very easy to adjust and move to match mission-specific goals. So in this case, it shows you a quick screen capture of what it looks like. So you can select points in the point cloud and then points in the image. And once you get at least 4, you can then create a camera mounting adjustment. So this isn't changing the lens model that we've calibrated ahead of delivery. This is changing the mounting or the physical orientation of the camera. So once you're happy with all of those, you can then begin the process of adjusting the imagery, which is a new feature that we've added this year, where we're able to greatly improve the overall image quality. So if we look at this real quick as an example, you can see we have near range targets. We're looking at this specific image here. You can see the raw image is quite dark, as often happens with the changing lighting conditions in a suburban, urban environment that you're often mobile mapping in. And then you can see the improved image clearly shows that I didn't collect this data because it's not in Florida. We typically don't get snow. But you can see very clearly how much improved that image is for recognition of what the sign is. And so if that was even darker, you could rescue it from even further back in the noise of the image. So a lot of great tools there to help improve the overall image quality that we're getting out from our high quality 12, 9, and 5 megapixel cameras. So then here we are colorizing the data. That's another thing you can do once you have everything aligned and happy. Looks pretty good. And then finally we get to exporting, right? So once you're all done, you're happy with it, it's good quality, you know it's gonna be very useful to the feature extractors down the road, you go ahead and export the data. So we have many different third-party software we can export to. You also have some plugins and some workflows that allow you to take data right into ArcGIS as well. Just not fully defined yet. So what do you do with this once you're done, right? So you get into feature extraction work, right? So you can see by this point cloud that's very rich in detail. There's a lot of things happening in this image, right? And the closer you get to it, the more you see. However, you can see all of that from just one photo, and you don't have to get any closer. You can see exactly the name of the building. You can see the exact features on the facade. You can see the individual bricks. So having images with the point cloud is very critical to being a fast, efficient feature extraction expert, because it gives those extractors clues. So that's why we focus a lot on merging the two together. All right, so now we're going to hear from my colleague, Dr. Harald Teufelsbauer.
Dear ladies and gentlemen, 10 years ago, with the introduction of RIEGL's first turnkey MLS system, the VMX 250, we decided that our goal needs to be to offer solutions in order to help our customers to take full advantage of the high-performance RIEGL laser scanners. In 2016, we did a huge step to pave the way for today's well-proven MLS product family. We introduced the RIEGL's first MLS system based on the VMX 1HA laser scanner, which is still known as one of the most precise and powerful scanners dedicated for mobile laser scanning. With the VMQ 1HA, we introduced a compact and lightweight single-head system, which is a perfect entry-level system for surveying companies. And many customers love the flexibility to use the VMX as a calibrated scanner plus INS subsystem to swap between MLS and ULS applications. Since traditional surveying, the VMQ is widely used for HD mapping, which is key for autonomous driving car industry. Regarding our flagship, the VMX, we have done a continuous evolution with respect to scanner performance and camera integration. With the VMX 2HA, we have taken the camera system to a new level that gives us so much options that we haven't had in the past. Our philosophy is to provide the customers with utmost flexibility to equip the VMX 2HA via plug-and-play upgrade with 1 up to 9 additional cameras. With regard to the laser scanners, we tripled the speed over the past few years, and in combination with high resolution and high frequency imagery, we can offer the perfect complement for mobile laser scanning. However, over all these evolutions, there seems to be a remaining constant, which is the principle of simultaneous forward and backward looking of two scanners. This principle remained untouched over a decade and is still the most popular configuration among various systems on the market. The two-scanner configuration hits a kind of sweet spot with respect to system size and weight, point density and field of view, but also in terms of investment costs.
Dr. Teufelsbauer, that was very well said. So, in concluding, I will add that if the 10 past years, or the past 10 years would be the proper way of saying that, excuse me, I'll start again. So if the past 10 years of mobile scanning with the VMX are any guide to the future, we can all agree that we are looking towards a very bright future for RIEGL mobile scanning systems in the next 10 years to come. So thank you, and I will take some questions now as we have about 5 minutes left before the half hour. So go ahead, type those questions, comments. All right, so we have a question about the targets. So the targets that I showed in there can be made with several different combinations. You can get the reflective traffic tape from different websites that make that. 3M makes that as well, in which you're able to basically just cut sheets off, and you can use the road for the checkerboard pattern as the dark area and use just 2 squares for the light, for the reflective part. It's always a good idea anytime you use new material or new to you material to do some test scans to see how the reflectance plays in your data set, because there are slight variations between material types, and so what might have worked really well 5 years ago may not work as nice. So if you just look up reflective traffic tape online, you can find it. Yeah, so we've been working very closely with Esri to bring our data into ArcGIS, and we have a consultant, Ron, who works very closely with us on pulling those two together. So if you have some RIEGL data, please reach out to us, and we will help you get it into ArcGIS. We've been able to do several test cases with them, and they will help out quite a bit. All right, so we're looking for some ballpark costs. Well, there's a lot of different options with the VMX and the VMQ systems. And since there's an international audience on today, I will email the direct cost associated with a US-based purchase to you directly, as it's always difficult to account for all the differences in customs and import fees for a variety of countries. So yes, the VMX 12 megapixel cameras can be integrated into the VMQ just like the VMX. This can be done with our IU box, so it's an additional add-on computer system. So with many VMQ1HA systems, there is a single laptop that is able to operate both the Ladybug 5 Plus camera and the VMQ laser scanning half of the system. But when you go to the RIEGL integrated 12 or 5 megapixel cameras, you then need to purchase the upgraded IU box, which has its own data storage locations for each camera to ensure data quality. Well, we are always trying to push forward the envelope, but right now the current speed limit on the rotating mirrors has been the 200 lines per second for the VUX1HA. We're always looking at new mechanical designs and changes to see if we can upgrade that, but I don't think that's very close at this point. We want the scanners to spin at very high speeds for very long lifetimes. And while the mirrors of airborne sensors may be able to spin faster, there are some differences in terms of the configuration of those systems comparatively to the smaller form factor of the VUX1HA. Yeah, so the Ladybug imagery can also be brought right into ArcGIS. There is a workflow for that. I'd be happy to share that with you if you email me. Well, the main determining factor of a minimum target size would be how many scan lines can you fit on that target at your drive speed. So at 40 miles per hour, if I do this in my head correctly here, you're going to have a line spacing on just a single scanner of about, well, let me pull up the calculator. So if we're traveling at 40 miles per hour, and let's say the target is probably about, we'll go 25 feet away, make it a challenge. All right, you can see that we're going to have line spacing. So the distance between each line is going to be about almost 3 inches. So there's going to be 3 inches of space. So you would want a target that was at least 6 inches to make sure you at least got 2 scan lines across it for each laser. Now the point spacing you're going to see very well, but you're going to want to go at least a half a foot, if not larger. So most of our target sizes are typically a 20 by 40 or a 40 by 60. So that's 40 millimeters by 60 millimeters. Sorry, centimeters. So 60 by 40 target. These are great questions. Thank you for coming in here. Yes. Okay. So to date, we're starting to get more requests about image blurring for license plate numbers and in people as well. There's some more requirements to do that. And while that's not yet a feature in our software, we're looking into that, but there are a lot of third-party tools out there that are having somewhat good success using. So we're not looking to add that immediately into our software, but definitely would recommend that you find a third-party software that does that quite frequently with the imagery. We really want our focus in our software to be on high-quality georeferencing of data and organizing the export of the imagery to match correctly with the point cloud that we produce. Yeah, so we do have a workflow to bring the point clouds. Someone asked, sorry, I keep answering the question with a statement rather than reading the question first. I apologize if that's confusing. We do work directly in ArcGIS Online is the main program that we're able to do. So yeah, so there's a lot of folks out there using AI embedded feature extraction methodologies, and they're getting to be more widely known and used throughout the industry. We're using some machine learning algorithms inside our own software, of course, for providing that information with respect to the target extraction. But we're not getting the true auto AI-enabled feature extraction just yet, but we're certainly adding more and more to that each and every day that we partner with more partners, because Esri has a lot of AI built right into the cloud to do certain applications, and there's a lot of work being done into that area simultaneously. But there's also a lot to be said for some other approaches for feature extraction, like the person in the loop feature extraction that's semi-automated, and you're just guiding it to help it answer difficult areas like what to do when a sidewalk comes up or a drainage inlet. So there's lots to be said for a blended approach between the program doing automatedly for you and someone then having to go back and check it, which is always the challenge, right? Well, that wraps it up. I thank you all for attending today. This program will be available in November at some point when we do our release for recorded webinars. And if you asked a question I didn't quite get to it or didn't quite answer it, I will reach out to everybody through email in the next couple days that attended. And I thank you again for attending, and have a great rest of your day.